So as you familiarize yourself with limits, the next two questions will be quite simple as well. So we have question number 61 that we're looking at. So it states that limit of the following function, right, as x approaches -6 equates to what value? And so the function here is x plus 6 divided by x squared plus 3x minus 18. So this is what we're looking at here. And again, the first step here would be to factor out the denominator, right? So we can just do that. Again, trying to look for two values that have a product of -18 and a sum of 3, right? And so we see that it should be x plus 6 times x minus 3. So this is what we're getting. Now, obviously, the x plus 6 in the numerator and the x plus 6 in the denominator cancel, right? So we have removed these two factors here, clearly showing us that there is a whole there, right? Again, that concept of wholes when we were graphing rational functions, right? If there were any common factors in the numerator and in the denominator, we would cancel them and say that there's a whole at -6 in this case, comma 1 over -9, right? That's how we would say that there's a whole there, again, because we would cancel out the factor set either one of the factors to 0, determine the value of x, and then plug that back into the expression in its simplified form. So -6 minus n would be -9, and obviously we have the 1 there. So -6 comma -1/9 would be the coordinate point of our whole, right? And that is really the removable discontinuity. So we can evaluate this, obviously, and so doing so, we know that it's 1 divided by x minus 3, right? Plugging it into the expression, we get 1 divided by -9. So limit of this function as x approaches -6 equates to -1/9. So that's question number 61. So now I have question number 62 here. Question number 62 again has same concept here, except we won't be using the formula a plus b times a minus b. You'll see why here in just a second. So we have limit of the following function as x approaches -2, right? And our function here is x cubed plus 8 divided by x plus 2. So the thing here is, and usually when you're first looking at this, obviously you want to plug -2 into the equation, right? And you get 0, therefore it's undefined. You know, at times what happens is there is a function, you can just directly substitute the value in, and you'll get a defined value, and then you're just set, right? That is your answer. But however, in most cases, they require you to factor, or really to remove that discontinuity, right? That removable discontinuity, so that you can achieve, or you can get your defined value. So looking at this, obviously, -2 plus 2 is 0, so we have an undefined value. The thing here is that you want to know this formula. A cubed plus b cubed is equal to a plus b times a squared minus ab, right? And then you have plus b squared, right? If you want to check, you could quickly say a cubed, right, minus a squared times b plus ab squared plus ba squared minus ab squared plus b cubed. A squared, b, and then we have plus a squared b here, right? These obviously, or not this, sorry, my bad. You have minus a squared times b, and then you have plus b times a squared, right? So obviously this and this cancel off. Then you have a times b squared. You have minus a times b squared. So these cancel off. You're left with a cube, right, plus b cube. So this is what you're left with, right? And so we can factor this numerator out, right? You just have to know its formula, right? Again, easy way to remember is a cubed plus b cubed is equal to a plus b times a squared. You have the minus here, right? So so for instance, if you have like a cubed minus b cubed, you would write a minus b, right? This sign over here matches this, and this sign over here matches this. Then you do times a squared. Now instead of minus, right, the sign switched. Here we would have plus ab, right? You're talking about 1ab, and then you always have b squared, right? So that will be the form for a cubed minus b cubed here. But that doesn't really matter. All we care about in this question is the first form. So here we can factor this out, right? We know that using this formula here, or this identity, we should realize that this is just x plus 2 times x squared minus 2x plus 4. Right, so this is how we have simplified this, and obviously we have x plus 2 in the denominator. Again, this is a good thing because our x plus 2's cancel out, right? And now we're left with limit of this function as x approaches negative 2. Well, all I would really do is plug the negative 2 into this expression there, right? So let's plug negative 2 into this expression. Well, negative 2 squared is 4, minus 2 times negative 2, that's plus 4, and we have plus 4. So limit of this function as x approaches negative 2 is equal to or equates to 12 here. So that's the answer to question number 62. Thanks for watching.